Hello everyone, welcome to this video where we are given the cross-sectional area of a water trough and the following dimensions. Find AD. Well, we could actually do this. I could join this line. I could also draw a vertical line. So once you do that right, our focus now becomes this. This is a vertical line. So now I know this part here is the same as this. So it's 40. So my job now is to find this length, which is actually the same as this length because all the sides are equal. Yep. And I also know that since this is 40, this basically means that we could have 40 here and 40 here. And I could apply my Pythagoras theorem. Given any right angle triangle, if I have my A and B as such, and label this as C, A square plus B square is equals to C square. And so I will be able to find the, and I'm going to label this as F and E. So I'm going to find my AF square. So from here, I'm going to just shift it here, AF square plus 40 square equals to my, 50 square. This is direct application of the Pythagoras theorem. Okay, so from here I will then be able to get my AF square easily, or AF square plus 1600 equals to 2500, and this will be equals to, I'm going to minus 1600 on both sides, and eventually I can get my AF, which is square root 900 to give me 30. So now I know this is 30, this is 30. So my AD is simply 30 plus 40 and plus another 30. 100 cm. We have come to the end of this video. So if you like this particular question solution, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we have a circle and a square. Well, this particular question do require us to draw some lines. So do take note, I'm going to break this square into two by drawing this EG, because they do give me the diameter, meaning EG I know already. EG is 20 cm. And because this is a square, we are actually looking at a right angle triangle here. And since we are dealing with right angle triangle, and I am going to do something, I'm going to write it down here. I'm going to let X be the length of the square that we are trying to, length of the side of the square. So I got x and x. And then I will then be able to apply my Pythagoras theorem, where it states that the sum of the square, meaning x square in this case, plus x square again, equals to 20 square. So how many x square are there? Yep, 2x square, 20 square is 400. So I will be able to get my x square pretty straightforward. 400 divided by 2, 200. So eventually, right, I will be able to get my x. Final answer, 3 significant figures. And therefore, turning back to the question then, the length of the side will then be equals to 14.1 cm to 3SF. With that, we have come to the end of this particular solution. So if you like this solution, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are given A, B, C, D is the cross section of a shed, and the following dimensions are given. We are required to find this. And for this particular question, it would be good if we could draw this line so that I can probably be able to get my right angle triangle. And why Mr. Tan do that? Because I do remember that given any right angle triangle, if this is my A, B and C, then let me shift it up a little. A square plus B square do give me C square by Pythagoras theorem. And so I would then need to find this particular length. So I'm going to just label A, B, C, D, E at this point here. So my length CE is pretty straightforward. CE is therefore equals to 2.5 minus 1.5 to give me 1 meter. And because I already know this length, AB is 2, so DE is also 2. So I will be able to get my CD square pretty straightforward by again applying Pythagoras theorem. So I will have 1 square plus 2 square, and this will be equals to 5. So my CD is square root 5, which will be 2.24 meter to 3SF. Well, we have come to the end of this particular solution. So if you like this video and this solution, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are given the position of 2 kites at A and B 50 meters above the ground. PQ. Find the distance A and B. And so, for this particular question, right, the first step is for us to find this length PQ. First, and to do that, I can focus my efforts on this right angle triangle. So, applying the Pythagoras theorem that you see on the bottom left hand corner, then I would have my PQ square plus my 50 square, and this will give equal to my 84 square. So from here I will be able to get my PQ square, which is simply 84 square minus 50 square to give me a value of 4,556. So my PQ is equals to the square root of 4,556. And I did not proceed on because this particular length, later on we will need it. Okay? Now though, I do want to channel our efforts to this particular line that I'm going to draw. And I'm going to label it as N for this particular point. So for this particular triangle, so at times it can be difficult to visualize, yeah? So this purple color triangle, I'm going to redraw it over here. To make us easier to visualize it. So I would have my 50 again. I will have my 67 here, and my PN is the thing that I want to find now. Okay, you take note, this is still a right angle triangle, because if I know that the whole thing is square root 4556, and if I can find this, then I will be able to find my AB. Yep. And so my PN, square plus 50 square is equals to 67 square. So therefore I'm actually applying the Pythagoras theorem again. I will be able to get my PN eventually as the square root of 1989. Again, I do not find the 3SF figures because this is the most accurate figure, and then I hope you guys can see that I will be able to get my AB now, because AB and NQ are the same. Yep. So finally, all we have to do is to just simply write down AB is equals to NQ, which is equals to my PQ minus PN, which is the square root of 4,556 minus the square root of 1,889. To give me the final answer, 22.9 meter to 3SF. With that, we have come to the end of this solution. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are given a right angle triangle. The very first thing that comes to my mind is that given any right angle triangle, if this is my A, B and this is my C, then when I color code it by Pythagoras theorem, A square plus B square will be equals to my C square. And that is what we can apply in this particular question. This will be my A, this will be my B, and this will be my C. And I can form an equation from here. So x plus 1 square and my x square is equals to my x plus 2 square. So all I have to do now is to expand and simplify. So this part here will give me x square after you expand and simplify plus 2x plus 1. I still have my x square here. This part here, when I expand and simplify, will give me x squared plus 4x plus 2 squared is 4. Then I continue to simplify further. Slowly and steadily. So x squared plus x squared, 2x squared. So Mr. Tan do this really slow and steadily, okay? And eventually I move all the terms to one side. So you will see Mr. Tan minusing x squared minus 4x and minus 4. And this one will become 0. So let's continue, okay? 2x squared minus 1x squared left only 1x squared. Positive 2x minus 4x. We are left with negative 2x. 1 minus 4, negative 3. And at this point, then I'm going to apply my cross chart to try and factorize this. X times x will give me x squared. For 3, it's only 3 times 1. This will give me 1x. This will give me 3x. And at this point, I just need to make sure which one could be my negative sign, because I get a negative 2x. And I know that the negative then must belong to the factor 3. So that when I have negative 3 plus 1, I will get negative 2. And I then are able to get my factors out. X negative 3, x positive 1 equals to 0. So one of the bracket must be equals to 0. And eventually I can get 2 answers. But we are actually talking about length. So right, when I go back to this question, if x is negative 1, what will happen to this? Negative 1 plus 1 equals to 0. Then this particular length will not exist anymore. And same goes for this. Can a length be negative? No. You're right. And therefore, I will have to reject this particular answer, since length cannot be negative. With that, we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.